This video may contain a variety of accents, so we apologize for the inconvenience it may cause.
In the summer of 2012, one of the most vital ecosystems on Earth experienced a crisis that alarmed scientists all over the world. Here, we're talking about the melting of the Greenland ice sheet.
What is ice sheet? Ice sheet is a mass of the glacier land ice extending more than 50,000 square kilometers. How do ice sheets form? Ice sheets form in areas where snow that falls in winter doesn't melt entirely over summer. And over thousands of years, the layers of snow pile up into thick masses of ice, growing thicker and denser as the weight of new snow, and ice layers compose the older layers. Next, I want to talk about Greenland ice sheet. Greenland ice sheet is a vast body of ice covering roughly 80% of the surface of Greenland. The ice sheet is about 2,000 kilometers long in a north-to-south direction and its greatest width is about 1,000 kilometers and a latitude of 77 knots near the northern margin. Greenland ice sheet has 1.8 million kilometers squares worth of ice. The average thickness of ice layer is about 2,000 meters. The amount of ice Greenland is 3 million cubic kilometers.
The Earth's climate is like a big engine for distributing heat from the equator to the poles, and it does that by means of ocean currents and wind currents. The scientists tell us that the Earth's climate is a non-linear system, in other words, that the changes are not all gradual, so some of them come suddenly. The increase of 1 degree at the equator means more than 12 degrees in the pole. And so all those wind and ocean currents patterns that have been formed since the last ice age and been relatively stable, they are all up in the air and they change. The ones we're worried about are the ones in the North Atlantic, where the Gulf Stream comes up and meets the cold winds coming of the Arctic over Greenland. And it evaporates the heat out of the Gulf Stream, and the stream is carried over Western Europe out of prevailing winds and the Earth rotation. The whole ocean current system is connected in a loop called ocean conveyor. The red lines represent warm surface currents, and the blue represent the cold currents running in the opposite direction. Up in the North Atlantic, after the heat is pulled out, what's left behind is cold water and saltier water, because the salt didn't go anywhere, and so that makes it denser and heavier. And so that cold density water then sinks at the rate of 5 billion gallons per second, causing sea level rise due to the change in ocean circulation.
The melting of Greenland's ice sheet is very important for various reasons. One of them is that it affects the sea level. How? Well, as the ice sheet melts, the sea level rises, so it's a direct proven effect referred to as the biggest concern over Greenland. According to scientists' estimates, if the entire ice sheet melted, sea level would rise 23 feet. However, its capacity to be a global-scale catastrophe depends on the velocity of the ice sheet's melting. That if occurred, 1/3 of the world's population that lives in or near a coastal zone would be affected. Large cities like New York, Beijing, Bangladesh, and Miami would be displaced. On the other hand, the impact of several billion refugees and the negative impacts on coastal economic activity would be staggering. And as if this scenario could not be more concerning, a sea level rise of only 2 or 3 feet, which are the high end of current plausible scenarios for the next 20 years, would create serious global problems such as increased coastal erosion, saltwater encroachment, loss of barrier formations like islands, sandbars, and reefs, and increased storm surge damage. On a historical note, sea level has risen more than 380 feet since the last ice age, 18,000 years ago. That's an average rate of 10 centimeters per decade or 10 millimeters per year. However, through the 1990s, the sea level rose at a rate of 3 millimeters per year, and it was followed by a 4 millimeter rate per year at the end of the last decade, resulting in a concerning fact that can very possibly derive in the scenarios explained. Another matter of importance regarding the ice sheet melting is ocean circulation, because if it melts at a faster rate, it will spread a slick of fresh water on top of the heavier salt water of the North Atlantic. This will have a direct effect on species which will have a hard time adapting to new temperatures, if it's even possible. Added to this crisis is the fact that many Arctic life forms rely on productivity of the sea, and change jeopardizes millions of them.
The loss of Greenland ice mass would affect global atmospheric heat movement. Any heat transfer is driven by a temperature difference. The greater the difference, the faster heat flows. As the polar regions form, the temperature difference between the equator and the poles is reduced, altering global atmospheric circulation patterns by reducing the force that drives equatorial heat towards the poles. If Greenland's massive range of ice melts, regional circulation patterns will also change. Climate change is projected to cause vegetation shifts because of rising temperatures favor taller, denser vegetation, and will thus promote the expansion of forests into the Arctic tundra and tundra into the polar deserts. The projected reduction in tundra and expansion of forest will cause a decrease in surface reflectivity, amplifying global warming because the newly forested areas are darker and more textured, and thus will absorb more solar radiation than the lighter, smoother tundra. Other effects include increased rate of disease due to changing temperatures, increased pollution impacts, increased competition among species.
Scientists believe it contains enough water to push up the sea level by 7 meters if it all melted, which would inundate almost every major coastal city in the world. Since 2003, Greenland has lost 10 billion tons of ice a year. Greenland ice sheet covers 1.7 million square kilometers, roughly 80% of the surface of Greenland. It is the second largest ice body in the world after the Antarctic ice sheet. The last time a melt this large happened was in 1889. The ice sheet consists of layers of compressed snow from more than 100,000 years.
The main problem is climate change. For this reason, the solution is to mitigate climate change by reducing greenhouse gas emissions. To reduce that, follow the following steps. First, you need to find out what your carbon footprint is in order to identify areas for improvement. A person's carbon footprint is the amount of carbon he or she is responsible for releasing into the atmosphere. Second, once you know your carbon footprint, you start thinking about ways in which you can reduce your footprint as much as possible. For instance, a lot of my footprint is coming from food. Then I might consider purchasing local foods instead and reducing the amount of meat I eat. Use public transport. Yes, public transport is a great idea, since many people ride just one vehicle, which divides the amount of carbon that particular vehicle puts into the atmosphere by the total amount of people riding it. If you still prefer to use your own car, try accommodating as much people as possible in your car. 4. Walk instead. 5. Unplug any appliances that are not being used. 6. Reduce, recycle, and compost. 7. And lastly, limit your use of hot water, since it takes a lot of energy to heat up water.
Thank you so much for your attention. See you next time. Do you have any questions?